Good morning, dear learners. Welcome to another fun and learning episode of Valenzuela Live Mathematics 7. I am Ma'am Eliakim Dugos from Valenzuela National High School, and I'm your live streaming teacher for this day. Make sure you have your self-learning module and materials needed as we go through our discussion. Are you ready to join me for today's lesson? Let us start. The focus of our lesson is on constructing triangles, squares, rectangles, regular pentagons, and regular hexagons, and solving problems involving sides and angles of a polygon. As we embark on our journey in Mathematics 7, let us familiarize ourselves with the most essential learning competencies of today's lesson. At the end of the lesson, the learners should be able to construct triangles, squares, rectangles, regular pentagon, and regular hexagon, and solve problems involving sides and angles of a polygon. I know that you're all excited about our topic for today. Let us begin with the activity entitled Identify Me. You have to identify what type of polygon the supplied picture represents based on the given image. Just click whether it's a heart or haha reaction. You have 5 seconds to type your answer in the comment section below. Are you up for it? Let's begin. Image number 1. What polygon does the cushion's front surface appear in? Is it a square or a triangle? 5 seconds. The answer is a square because the cushion's front surface is square-shaped. Very good. Image number 2. So how does the picture look? Is it a hexagon or a rectangle? 5 seconds. The answer is a rectangle. Yes, you got it right. Because the front surface of a blackboard is a rectangle in shape. For image number 3, what does the picture look like? Is it a triangle or a pentagon? 5 seconds. The answer is a triangle. Yes, the front side of a pizza slice is formed like a triangle. Keep going. Now, for image number 4, what is the appearance of the image? Is it a pentagon or a hexagon? 5 seconds. The answer is a pentagon. Correct. The school zone signage is in the pattern of a pentagon. Picture number 5. What does a wall clock look like? Is it a hexagon or a rectangle? 5 seconds. The answer is a hexagon. Yes, a wall clock is hexagonal shaped. Very good, grade 7. I am very glad that you enjoyed the activity. The pictures that are shown in our activity are like pictures of a polygon, formed like a triangles, squares, rectangles, pentagons, and hexagons are examples of polygons that can be found all around us. When you look around, you will notice that the majority of the objects have these shapes. In mathematics, we try to understand and create such shape. We can begin by constructing these shapes around it or in the form of another object. You want to learn how to work with this figure? Okay, join me in making different polygons out of these resources. You'll need to have a compass, a straight edge or a ruler, a pencil, and some paper. Now we go first to triangles. Did you know that triangles have affected history from Euclid to present? They can be found almost everywhere and even make up the world-famous Egyptian pyramids. A triangle must have three sides. A triangle with three congruent sides is known as an equilateral triangle. A triangle with at least two congruent sides is an isosceles triangle, while a triangle with no congruent sides is known as a scalene triangle. But how are we going to construct a triangle? The steps to constructing a triangle are as follows. Use the three given segments. Draw a ray. Place the point of the compass on the end point of a ray and open it equal to the longest side of the given segment. Make the compass opening equal to the length of the second longest side and draw an arc, with the point compass still on the end point. Make the compass opening equal to the third side and the compass point on the second longest side end point. Then connect the points and label them with any letter. The construction points are denoted by a capital letter. Kindly watch this video in constructing a triangle.
Construct a triangle with three sides measure X, Y, and Z. Use the three segments given. Draw ray XP. Place the point of the compass on X and open it equal to Z. Make an arc intersecting ray XP at Y. Make the compass opening equal to Y and draw an arc with the point of the compass still on X. Make the compass opening equal to X and its point on Y. Draw an arc. Connect the point X and Z along with Y and Z. Here's now your triangle XYZ.
As a result, segment XY is equal to Z. Segment XZ is equal to Y. And segment YZ is equal to X. The next constructing a triangle with sides of 8 cm, 6 cm, and 5 cm. Watch this.
Constructing a triangle which sides measures 8 cm, 6 cm, and 5 cm. First is you're going to draw a segment in which the measurement is 8 cm using a ruler. Then mark as segment AB. With the point of the compass on A, make its opening equal to 6 cm using a ruler and make a big arc. With the point of the compass on B, make its opening equal to 5 cm using a ruler. Then make a big arc. Connect point A to C and point C to B. Here is now your triangle ABC. Segment AC is equal to 6 cm, segment AB is equal to 8 cm, while segment BC is equal to 5 cm.
This is our triangle ABC with the segment AC equals to 6 cm. Segment AB is equal to 8 cm. And segment BC is equal to 5 cm. As you can see, our triangle has different measures. Since the three sides are not equal, we call it a scalene triangle. The next is with given two sides and an included angle. We'll now create a triangle. Here are the steps. Copy the given angle. With the compass point of the vertex of the copied angle, make the width of the compass equal to the given smallest side. And make an arc on one side of an angle. With the compass point still on the vertex of the copied angle, make the width of the compass equal to the second given side, and make an arc on the other side of an angle. Then connect the points to form a triangle. Again, you can label it with any letter. Reminders, the points are denoted always by a capital letter. Let's construct now. Watch this.
Constructing a triangle with sides measure DE and the included angle X. Copy angle X. Draw a ray on the right side. Place the point of the compass at X and draw an arc intersecting the sides of an angle. Then using the same opening of the compass, place the compass point at the endpoints of the ray. Measure how wide is the intersected arc of the angle and make sure it has the same width. Connect the endpoints and the intersected arc and let the sides of the angle be ray CP and ray CQ. The compass points on C, make the width of the compass equal to D. And make an arc on ray CP. With the compass point still on C, make the width of the compass equal to E. And make an arc on ray CQ. Mark the point D. Connect D and E to form triangle DEC. You have now your triangle DEC with a side DE and the included angle.
Here's our triangle, which has two sides given as well as the included angle. We'll now proceed to construct a square. So here are the steps in constructing a square. First, we're going to draw a line segment and label it with any letter. Extend the line segment to the right. Next is construct perpendicular to the segment at any letter. With the compass opening equal to the segment and the compass points at one end point of the segment, draw an arc intersecting the perpendicular to the segment using any letter. With the same opening of the compass and the compass at the other end point of a segment, draw an arc. With the same opening and the compass point at the end point to the segment perpendicular to the first segment, draw an arc intersecting the arc drawn in step 5. Then draw the square. Again, the points are denoted by a capital letter. Let's construct now. Watch this.
Constructing a square KLMN given segment KL.
Extend point L. Construct a line through point L that is perpendicular to segment KL. With the compass at point L, draw an arc intersecting across the line.
From each point arc, draw an arc above point L. Connect point L and the intersecting arc. With the compass opening equal to KL and the compass point at L, draw an arc intersecting the perpendicular to segment KL at M. With the same opening of the compass and the compass at point K, draw an arc. With the same opening and the compass points at M, draw an arc intersecting the arc at N. Draw the square.
This is KLMN, R square. A square is a parallelogram with 4 right congruent sides and 4 right angles. Next in construction is a rectangle. The steps to constructing a rectangle are as follows. First is draw a line segment with a given length. Construct 2 perpendicular segments. Using a ruler, connect the intersected arcs to one end point and another intersected arc to the other end point. Label with any letter. After that, connect the points. Again, the points are denoted by a capital letter. Let us construct now. Watch this.
Constructing a rectangle with a length of 8 cm and width of 5 cm. Draw a line segment MA with a length 8 cm using a ruler. Construct 2 segments perpendicular to one another. Place the compass point at M and adjust compass opening. Draw 2 arcs intersecting across the line. From each point of the arc intersecting the line, draw arcs above M. The compass point at A and adjust compass opening, draw 2 arcs intersecting across the line. From each point of the arc intersecting the line, draw arcs above A. Using a ruler, connect the intersected arcs to M by 5 cm and another intersected arc to A by 5 cm. Label as T and H. Connect their endpoints. Its measure should be 8 cm. Segment TH is equal to segment MA, while segment MT is equal to segment AH.
This is rectangle MATH. A rectangle is a parallelogram with all equal angles. The opposite sides are equal in length. We go now to a pentagon. How we're going to construct a pentagon. Here are the steps. First, draw the horizontal and vertical lines. Then draw the circle centered on the crosshairs. Do not pull the compass after the circle is drawn. Without adjusting the compass, place the point of the compass on the circle where it crosses the horizontal line. Now, draw arcs on the previous circle above and below and connect those points. Now, center the compass on the crosshair made from the bisector and draw an arc from the top of the circle down to the horizontal line. At the end of this step, do not close the compass. You will need that distance to make 4 more arcs. Putting the point at the compass at the top of the circle, draw an arc. From where the last arc intersected the horizontal line out to the circle. Now, move around the circle using each arc as the center of the next arc. And finally, draw lines from each intersection to form a pentagon. Let us construct now a pentagon. Watch this.
Construction of a pentagon. Draw diameter GH on circle C. Construct a line that is perpendicular to GH and intersects the circle at I. Draw the perpendicular bisector of CI, creating its midpoint J. Circle J with radius IJ. Draw HJ intersecting at circle J at K. Draw an arc intersecting the larger circle at M and end with the compass set to H and the radius set to HL. Draw an arc intersecting the larger circle at P and Q with the compass set to H and the radius set to HK. Connect G and P for side GP.
Connect G and Q for side GQ.
Connect Q and N for side QN. Connect P and M for side PM.
Connect M and N for side MN. There you have it. We now have our pentagon.
Here's our regular pentagon, P, G, Q, and M. A regular pentagon is a polygon with 5 equal sides that are the same length and have the same angle. The next construction is a regular hexagon. The following steps are as follows. First, draw a segment. Adjust the compass equal to the segment. Draw an arc above with the segment as the compass width and one of the endpoints as the compass point. Draw an arc above with the segment, intersecting the arc as the compass width and another endpoint as the compass point. Draw a circle with the same compass width and the compass point at the intersected arc. Draw an arc intersecting the circle with the same width and the compass point at one endpoint of the segment. Draw an arc intersecting the circle with the same width and the compass point at the intersecting arc in the previous step. Repeat in this way until 2 vertices were created. Then connect the adjacent vertices. Are you ready now to construct? Watch this.
Constructing of a hexagon. KL as the side. Adjust the compass with equal to segment KL. Draw an arc above with KL as the compass width and K as the compass point. Draw an arc above KL, intersecting the arc at M, with the same width at the compass point at L. Draw circle M with the same compass width and the compass point at M. Draw an arc intersecting the circle at N with the width KL and the compass point at K. This is the regular hexagon's third vertex. Draw an arc intersecting the circles at O with KL as the width and the compass points at N. This is the regular hexagon's fourth vertex. Repeat in this way until vertices PQ were created. Connect the vertices. Connect point K to point L, from point L to point Q, and point Q to point P, from point P to point O, and from point O to point N, and from point N to point K. Like the result, you'll have one regular hexagon.
Here's now our hexagon. O, P, Q, L, K, N. A regular hexagon is a close 2D shape made up of 6 equal sides and 6 equal angles. We've completed our triangle, square, rectangle, regular pentagon, and regular hexagon construction. We'll do our activity first before moving on to the next topic. Our activity is called Let's Construct. You will be given 1 minute to construct this polygon. Let's get started. Construct a regular hexagon with a side measure equal to 5 cm. Your timer starts now. Time's up. If you construct like this regular hexagon with 5 cm, grade 7, you did very well. Now that we've learned the construction of triangles, squares, rectangles, regular pentagons, and regular hexagons, let's move on to the next step. Let's look more closely at the polygon sides and angles. We'll go through how to work with polygon sides and angles to solve problems. For us to understand this better, let's think of this. The given triangle is an equilateral triangle. Equilateral triangle has 3 equal sides. Each interior angle measures 60 degrees. Thus, in one triangle measures 180 degrees. Figure number 2 is a quadrilateral. How many triangles can be formed from a quadrilateral when diagonal is drawn without overlapping? We can form two triangles. Thus, one quadrilateral measures of 360 degrees. Next, figure number 3, a pentagon. How many triangles can be formed from a pentagon when diagonal is drawn without overlapping? We can form 3 triangles. Thus, one pentagon measures of 540 degrees. But how about a nonagon? How about a 20gon? From that, we can have our formula to find the sum of interior angles of a polygon is S sub n is equal to 180 degrees multiplied by the quantity of n minus 2, where n is the number of sides. And the formula of the measure of each interior angles of a regular polygon is m sub I is equal to 180 degrees multiplied by the quantity of n minus 2 divided by n, where n is the number of sides. And for the measure of each exterior angles of a regular polygon is m sub E is equal to 360 degrees divided by n, where n is the number of sides. Let's have problem number 1. The sum of interior angles of a regular polygon is 1080 degrees. How many sides does the polygon have? By applying the formula for the sum of the interior angles, S sub n is equal to 180 degrees multiplied by the quantity of n minus 2. Substitute the given to the formula, and the given is 1080 degrees. Therefore, we have 1080 degrees is equal to 180 degrees multiplied by the quantity of n minus 2. And by division property of equality, we're going to divide both sides by 180 degrees. We have 1080 degrees divided by 180 is equal to 6. And 180 degrees multiplied by the quantity of n minus 2 divided by 180 degrees, we have n minus 2. Then, by addition property of equality, we're going to add both sides by 2. So, 2 plus 6 is equal to 8. And n minus 2 plus 2, we have n. Therefore, the sides of a polygon is 8. Since the sides of a polygon are 8 sides, so the type of polygon is an octagon. For problem number 2, determine the measure of one of the interior angles of a regular nonagon. By applying the formula for sum of the interior angles, we have m sub I is equal to 180 degrees multiplied by the quantity of n minus 2 divided by n. Then, the given, a regular nonagon has 9 sides. So, we're going to substitute the value of n to the formula. So, we have m sub I is equal to 180 degrees multiplied by quantity of 9 minus 2 divided by 9. Next, we have m sub I is equal to 180 degrees and 9 minus 2, that is 7, divided by 9. M sub I is equal to 180 degrees multiplied by 7, that is 1260 degrees, and divided by 9, so m sub I is equal to 140 degrees. Therefore, the measure of one interior angle of a regular nonagon is 140 degrees. For problem number 3, What is the measurement of an exterior angle of a regular pentagon? By applying the formula for the measure of each exterior angles. So, we have the formula m sub e is equal to 360 degrees divided by n. Based on the given, the value of n is equal to 20, where n is the number of sides. Substitute the value of n to the formula. So we have the measure of exterior angle is equal to 360 degrees divided by 20. So the measure of exterior angle is 18 degrees. Therefore, the measure for each exterior angle of a regular pentagon is 18 degrees. For problem number 4, Mr. Salvador's land is shaped like a pentagon. Two of the pentagon's interior angles are right angles. The remaining three are congruent. What is the measure of each of the angles? First, we're going to sketch to visualize the given problem. Label a diagram for land shape. So we have pentagon, P, E, N, T, A. As we can see, it is a non-regular pentagon. The right angles are angle P and angle A. The remaining angles are congruent, which are angles E, N, and T. The sum of the measure of the interior angles of the pentagon is 540 degrees. The measure of the interior angle of a pentagon, again, are 540 degrees. While the measure of each right angle is equal to 90 degrees. And the measure of angle E, angle N, and angle T is equal to x degrees. For our solution, we have the formula S sub n is equal to 2 multiplied by the right angles added by 3 multiplied by the congruent angles. Next, S sub n is equal to 540 is equal to 2 multiplied by the measure of a right angle, that is 90, added by 3 multiplied by x. So we have 540 is equal to 2 times 90, that is 180, plus 3 times x, that is 3x. By subtraction property of equality, we're going to subtract both sides by 180. So negative 180 plus 540, that is 360, is equal to 180 plus 3x minus 180 is equal to 3x. Then, by division property of equality, we're going to divide both sides by 3. 360 degrees divided by 3, that is 120. And 3x divided by 3 is equal to x. So therefore, the measures of each 3 congruent angles is equal to 120 degrees. Now, let us check if our answer is correct. Upon checking, so again, we use the formula of S sub n is equal to 2 multiplied by the measure of a right angle plus 3 multiplied by the measure of congruent angles. Then, we have 540 degrees is equal to 2 multiplied by 90 degrees plus 3 multiplied by 120 degrees. 540 degrees is equal to 180 degrees plus 360 degrees. So therefore, we have 540 degrees is equal to 540 degrees. So therefore, our answer is correct. That concludes our problem solving with polygon sides and angles. We offer an exercise called to get the correct answer. That can help you learn more. All you have to do is choose the students who correctly answered the question. You have 10 seconds to answer, and you must type your answer in the comment section below. Ready? Let's have this. Number 1. Find the sum of the interior angles of a regular hexagon. Is it Angel? Answered 120 degrees. Or Alexa? Answered 720 degrees. Or Paul? Answered 1080 degrees. Your timer starts now. And the answer is Alexa, 720 degrees. Number 2. If 2,340 is the sum of an interior angles of a regular polygon, how many sides does it have? Is it Angel? Answered 15 sides. Alexa, 16 sides. Or Paul? Answered 17 sides. 10 seconds. And the student got the correct answer is Angel, which is 15 sides. Excellent. Moving on to problem number 3. What is the measurement of an exterior angle of a regular triangle? Is it Angel? Answered 60 degrees. Alexa, 120 degrees. Or Paul, 180 degrees. 10 seconds. And the correct answer is Alexa. Answered 120 degrees. Very good, grade 7. I hope you enjoyed today's activity. To sum up today's discussion, we construct the following polygons, like triangle, square, rectangle, regular pentagon, and regular hexagon, and solve problems involving sides and angles. And for the formulas in solving sides and angles of a polygon, we have for the sum of the measure of interior angles of a regular polygon, S sub n is equal to 180 degrees multiplied by the quantity of n minus 2, where n is the number of sides. And for the measure of each interior angles of a regular polygon, we have m sub I is equal to 180 degrees multiplied by the quantity of n minus 2 divided by n, where n is the number of sides. And for the measure of each exterior angles of a regular polygon, we have m sub b is equal to 360 degrees divided by n, where n is the number of sides. Here is one of the frequently asked questions by the students. Are all regular polygons can be constructed by a compass and a straight edge? In mathematics, a constructible polygon is a regular polygon that can be constructed by a compass and a straight edge. For example, a regular pentagon is constructible with a compass and a straight edge, while a regular heptagon is not. Not all regular polygons are constructed by a compass and a straight edge. For our home weekly learning task, answer the given activity. For our quotes for today, our life is a polygon. Since we get different people with different sides. Being different makes you who you are. It means you dare to stand out from others and live your own life. That's all for today. See you again in the next Valenzuela Live. This is Ma'am Eliakim Dugos from Valenzuela National High School saying thank you for joining today's journey. Good day and God bless.